What's up guys and girls, Raj here, back with another video. In this system design video, we will learn monolith versus microservices, but from an AWS angle. Not only we will learn the characteristics of microservices and what advantages does it have, but we will look at design patterns and how to implement microservices on AWS or in any cloud in general. Alright, let's get started. Before we learn about microservices, let's take a look at the elephant in the room, the monolith. Monolith is a single-tiered software application in which the user interface and data access code are combined into a single program from a single platform. Some examples of monolith are a single Java jar file which handles business logic for different areas of your project, or a COBOL program handling different functionalities. Monolith is not really the bad guy, because at first monolith is simple, especially for small projects. Since everything is contained in a single code base, there is no over-engineering. It is also resource efficient at small scale. But as your projects begins to grow, modularity is hard to enforce. Scaling is a challenge, so this is the important part to understand, especially during the interviews, so we'll dive deep into the scaling part. Monolith has all or nothing deployment because everything is contained in a single code base. Either the whole jar file or the whole COBOL file goes in, or everything gets backed out. Monolith leads to long release cycles because over the time that single code base gets bigger, so even if you are not touching some functionality, you still need to test it out to make sure they are not impacted because they are part of the same code. Hence, the businesses are slow to react to customer demand. Now let's talk about a very common misconception. Can you use API with monolith? Absolutely. APIs has nothing to do with monolith or microservices. Your monolith can be fronted by an API gateway or a load balancer. And when different URL or paths hit this API gateway/load balancer, they could forward all these calls to the same monolith. And this monolith will have an entry function or entry paragraph which will check the URL or path and invoke different functions within the monolith and executes the logic accordingly. Now let's talk about the scaling of monolith. Let's say our monolith is running on virtual machine. And since you are running this huge program as one executable, you need a sizable EC2 instance. In this example, this EC2 is M5.12x large, and we have these three different traffic patterns coming in for store/get, store/post, and store/delete. So as the name suggests, you can imagine store/get gets some information about some product, store/post posts information about a product or a customer or a purchase, and store/delete deletes information from the database. So let's say the traffic for store/get increases. So the CPU, as you can see, increased to a threshold limit. And if you have auto-scaling group set for this virtual machine and the threshold for that auto-scaling configuration exceeded, which it is in this case, instead of scaling just the CPU needed for the store/get component, you have to scale the entire monolith, right? Because you cannot really pick apart different components to run on different EC2s with the monolith approach. So now we have two M5.12x large EC2s running, and the CPU utilization for both of those went down. So even though you are using part of the CPU, you still pay full price for these Amazon EC2s. Since you have to assign a sizable virtual machine for monolith, so you end up paying a lot more. So how would it look like with a microservice? So with a microservice, all the three components, store/get, store/post, and store/delete have different code bases. And on the back end, you can see they are running on different virtual machines. And depending on the type of the API, you can control the memory and CPU of the EC2. In this case, store/get backend is running in a T3.large, store/post backend is running in T3.medium, and store/delete backend is running on T3.micro. Now you might say, Raj, this is not a right microservice because each microservice should have their own different database. Ideally, yes, but in real world scenario, it is not possible sometimes to break the big database into multiple small databases. So we are going to talk about the characteristics of microservices, but remember that it is not all or nothing approach. In real world enterprise projects, you fulfill some characteristics of microservice that makes your business agile and makes your life easier, but it doesn't need to check all the boxes. So going back to our previous example where our code base is separate and it is using the same database, now let's say store/get traffic increases. Instead of scaling up all the 3 different EC2s, only the virtual machine that's running store/get backend needs to scale. If you are using the single database for multiple microservices, you do need to keep in mind as the microservices scale, the database should be able to handle the increased connections. Generally, there are a lot of techniques to optimize the reading from the database, such as you can use read replica, caching, etc. Another advantage of using microservices is since all these backends are independent of each other and could be maintained by different teams, these microservices can be written in different programming languages. So the store/get could be written in Python, store/post backend could be written in Node.js, and store/delete backend could be written in Go. There is a fancy name for this feature. We call it polyglot. So what are the characteristics of microservice architectures? The core property is each microservice is independent of each other. So each can scale irrespective of each other, as we saw. Since they are separate, you can apply different governance and security features, and you can deploy each of them independently. This makes your DevOps much faster and simpler because it is no longer an all or nothing approach. You can just deploy store/post backend without deploying store/delete or store/get. You can test these microservices independent of each other, and they should have different functionalities. And as I mentioned before, the important thing is it is not required to follow every characteristic. The main characteristic is independent scaling and independent functionality. However, like I mentioned, sometimes you will see the same database being used for more than one microservices. Now that we understood about monolith versus microservices, let's talk about how can you implement microservices in AWS. So we have one service which is answer to everything, and that is Amazon EC2. There is a misconception that you cannot run microservices on Amazon EC2, which is not correct. So as we saw before, each microservice can be running in their own Amazon EC2. Each of those Amazon EC2 could be part of different auto-scaling groups with different scaling criteria. You can select appropriate Amazon EC2 family based on the nature of the microservice. So if some microservice is memory intensive, you can select a higher memory EC2, and you can scale based on memory instead of CPU. You can use Elastic Load Balancer or Amazon API Gateway to host those microservices. Beyond EC2, for modern application development, we can look at the serverless alternative, which is AWS Lambda, where each microservices backend will be implemented in separate Lambda functions. Remember that Lambda scales automatically, so there is no auto-scaling group in this case. And Lambda could also be fronted by Elastic Load Balancer or Amazon API Gateway. Now, another popular choice is using containers. You can containerize your application and run within Amazon Elastic Kubernetes Service or EKS or Amazon Elastic Container Service or ECS. And in this case as well, you can front it by using Elastic Load Balancer or Amazon API Gateway. So let's zoom in into the Kubernetes part, because Kubernetes is super popular right now and this might come up in your interviews. So for Kubernetes, each microservice will be fronted by different services, so service A, service B, and service C, and the code for each microservice will be running in a container, and this container will run in a pod. And all these will be fronted by a single ingress, which will be an application load balancer. Now, this is a deeper topic which is beyond the scope of this course. If interested, check out my container and Kubernetes course in Udemy. Since each microservice is independent of each other and can even be coded in different programming languages, you can mix and match all these AWS services. So for example, store/get can run on a pod where your backend of the microservice is Dockerized into a container. Store/post can be hosted on Amazon EC2, and store/delete can run on AWS Lambda. So which one should you choose? So the answer is it depends. Based on the requirement of the project, you have to choose different backend for the microservices. One general tip is, for interview, go with the service that you are most comfortable with, if you have a choice to pick one. Alright guys and girls, that's the video. If you found this video helpful, if you learned something new that would help your cloud career, please click that like button, smash it if that's something you are into, and subscribe. This is still a small channel, I'm trying to grow, so your every like matters. So it really helps YouTube algorithm to suggest this video to the like-minded viewers. Also, let me know in the comment sections if you have any questions or what other kind of videos you are interested in. Check out my container and Kubernetes playlist, which can teach you some of the critical Kubernetes components. Alright, that's it for this video. I'll see you guys and girls in the next video. Bye!